Hi, my name's Dominique and this is my presentation on the comparison of stop signal and continuous movement reaction stop times to measure inhibitory control for the University of Oregon Undergraduate Research Symposium 2020. So in 1984, Logan and Cohen developed the stop signal task, which was a motor inhibition task to measure inhibitory control. This task measures an average SSRT over a group of trials when a participant stops a planned movement from occurring. This has been one of the main ways of measuring inhibitory control over the past few decades. And so in 2019, Verboegen and colleagues developed and published a new version of this that can be administered online. And while very useful, this task does have some limitations in that you can't get any stopping measurements for individual trials. It's only an averaged over all the trials. So to try and overcome these limitations, we've developed a novel continuous movement stopping task to try and answer the question, how does stopping a continuous movement as implemented in our novel task compare with stopping in the standard stopping task? So we had participants come in between June 2019 and March 2020 to complete the continuous movement task. So in 70% of the trials, it'd be a planned stop trial, which means the participant would have their right hand on the mouse and they'd have a ready, set, go cue, and then they'd start and move their mouse in a clockwise direction to make a circle, having 1 revolution per second, so 6, 5, 4, and so on, until the countdown ended and they had a stop signal, and that's when they stopped their movement. In 30% of those trials, however, there was an unplanned stop, which means the stop signal would appear early or before the end of the countdown, and a participant would have to stop their continuous movement abruptly or before they had planned to. And in the stop signal task, which we've started data collection for in May 2020, there are 2 different types of trials. So in 75% of the trials, the participant's going to get a go trial, which means they get the fixation cue, which is the black dot, which is kind of a heads up that the trial is about to start, and then 2 white arrows either pointing in the left or right direction. If they point in the left, the participant is to respond with pressing the left arrow key on the keyboard, and if it's to the right, with the right arrow key. However, in 25% of the trials, the arrows will turn red after a varying amount of time, and the participant has to stop themselves from responding by hitting one of the keys. So looking up in the results section, figures 1 and 2 show us the SSRTs of the participants for the continuous movement stop task. And figure 1 just shows unplanned and planned, but for the participants that did not have a constraint or didn't have anything around their hand. And then the figure on the right just shows them for participants who did have a constraint, which is just dictating the diameter of the circle that the participants could make with the mouse. The table below shows the SSRTs for the continuous movement stopping task in the right column, and in the left column will show the SSRTs for the standard stopping task. Data collection is ongoing, so wherever an X is, there's not been data collected yet for those participants. Looking at those figures from the continuous movement task so far, we can see that unplanned stopping is slower than planned stopping. Thank you so much for listening.